All right, everyone, we're going to start right now. So the only thing I have to ask you before I introduce myself and everything else, the Ethernet is not working. I have to use Wi-Fi. Please don't run Maven, npm install. Don't download the internet with me, please. Wait, I need the internet for demos. Please. Cool, so I'm Heitor Lessa. I'm a specialist solutions architect for AWS. All I do on my normally daily basis is all about developer tech. So think about all the buzzwords, microservices, DevOps, serverless, containers, a bit of everything. Because this is just too much to do on a daily basis, I try to focus on serverless. Today, it's all about GraphQL. I will show you a bunch of services and give you a demo about how to run WebSockets much more easily with some little tricks, and also a bunch of other stuff, more for a mobile front-end type of thing. If you're interested in other stuff, I will make probably a propaganda at the end of the demo. So I have 2 more sessions to come today. If you want to hit me up, this is my Twitter. Feel free to send me messages or anything like that. I was going to add my email address, but it just became very difficult to reply to emails. Twitter is easier. When we talk about offline and capabilities like this for mobile, the first question you should ask before we add more services and more components to our application is that, well, why do I need this? If you actually I'd say more than 90% here have heard of something called WhatsApp, or heard of actually other Monzo Bank or many other applications that actually allow you to have a better offline experience. And when something happens as well, you also get real-time notifications. You get some cache, you get a notification. You actually receive a message, you get a notification, or a message has been delivered. All of this has changed the way users actually see experience, and they would definitely ask you the same. Customers are no longer asking you to say, you're a retailer compared to other retailer, the price is cheaper, et cetera. Well, they do, but now they're actually comparing the experience they get from Uber and many other apps, like WhatsApp and so forth, and they look at yours and they say, well, I need a better experience. Not all the time I have internet. You know how people freak out on planes because they don't have Wi-Fi, right? So before I get to all of this, you might be new to serverless, so I just want to do a very quickly brief in what it is and what it means and what the building blocks are, and then we focus only on GraphQL and get to go. I try to divide this in 20-minute slides max. Everything else will be just hands-on demo. When we talk about serverless, we have a lot of jokes, and if you probably ask 1,000 people what serverless is, you probably get 1,000 answers. So just to set the pace, yes, there are servers. You just don't have to care about them, right? And AWS has its own definition about serverless. When we talk about serverless to customers, we try to classify AWS services into these 4 quadrants. If they don't fit into those, for now, it means it's not a serverless service. But at the same time, it's also important that you're not going to build fully fledged applications just using Lambda or just using API Gateway. You need more to this. You need a data store. You need so many other services that have to come together in order to build an application. A lot of customers also ask, is this Lambda just or serverless just for a image classification or image resizing or something like this? Even though we do heavily showcase on how many customers are actually doing something more meaningful, there's still something we have to talk about, which is this is the 4 common or most common across all the industries and across every country I've possibly been that I've seen customers doing this, at least one or the other. And usually they start with one and they go over the other. In the UK in particular, it's very common to see the autonomous IT first, policy engines, automating infrastructure on AWS, and then they start going for analytics and backends and mobile and web apps and so forth and so forth. Like I said, you cannot build everything just using Lambda. We're not going to have enough time to cover all of these services in more details. But at least I need to tell you that this is what most customers will use when building a serverless applications. They need additional building blocks. Otherwise, they will not have every feature they have. So for now, we're only going to focus on the real-time backend, which is AppSync. If you haven't seen AppSync, we announced AppSync last year, and we have been iterating that quite fast. It actually went GA a few weeks ago, actually about a month, I think. But I will actually show to you in more details on what that means. Probably you heard of something called REST API. I can see some people are almost doing like this on their faces. Yes, I see that. But not everyone, for some reason, heard about GraphQL. In the same way, I'd like to say there's no silver bullet. I don't think there's a particular technology that will solve all your problems, but actually knowing that they exist and how to apply them, that's important. That should be your key messaging in this place. So GraphQL is actually what will allow us to do these demos for today, and also allows us to give a better experience for customers and giving more real time, and actually allowing the client to select actually what they want as a response. Think about something in the past called Backends for front end. That used to be a very famous architecture design where in the past you didn't see many mobile customers. So you would see mostly a desktop and sometimes a web, and that would be it. A mobile application maybe require only part of the data that you're sending as an API. They may not need everything. And you may have an iOS app, and then you have an Android app. That becomes convoluted because you ended up creating an API for mobile applications, an API for desktop, an API for web. That's difficult to maintain. So backend for front end is great for some pieces, but also difficult to maintain in the long run. GraphQL, this is not to say GraphQL is always better than REST, but in this particular scenario, it is. Think about where you need to provide some posts. Think about a blog post or something. And you need to provide multiple details in multiple different views. One sometimes wants to see all the posts available. Think about medium.com. But other parts, you only want to know how many you have and actually some stars, reviews, or details, description, title, you name it. If you have to keep adding additional path on your REST API, you probably ended up with hundreds of those at some point. So this GraphQL is a query language actually created by Facebook a while ago that allows you to give the power to the client. The client will say, this is the API that I'm going to connect, this case /post, and I want only the title, the description, or something in there. The server doesn't do anything else. The server continues to expose the same API, and the client now has more control on what they want. Think about countries where internet is not that great, where I come from in particular, in Brazil or other places. One of the nice benefits about GraphQL is you have a schema. About schema, there's a lot that comes into play. This is to show you how you actually would create a to-do type of a list, where to-do would have the name, description, priority, and all this stuff. And then you will only expose the top one to the client, which is get to-dos. I will show that in a code, hands-on, explain what it is, but I will, for now, stick with that. Later, you want to query that data from the client, or you want to query that from the console. All you have to do now, you actually say query, which is what GraphQL expects you to do. And then you could also give the name of the query, and then you say ID, name, priority. If you actually don't want any of these fields, you just remove and stick with the names or the properties that you want. And that's it. GraphQL will do the magic and will return only what you want. This is an example of how you could actually get these returns. And by the way, we also do pagination for you and a bunch of other stuff. Let's try to wrap that up into a better way to explain this. First, you have to have a schema, right? Your data has to be somewhere. GraphQL will only do the querying for you, and will actually return in a way that the client expects. But you still need to define that schema somewhere, and you need to store that data somewhere. So first, you get the schema. You can see that the comments inside the event will actually go to comments, and they might be using different tables. So in this scenario, we're actually using one DynamoDB table for event and one DynamoDB for comment. Think about making a query for multiple tables. If you were to do that today, you would have to use batch, get, items, and so forth. AppSync will do that for you already. So think about now you can even do data relationship between all these tables in a much more easily fashion. You need to change data. How do you change data? In GraphQL, the term is called mutation, which is not probably so new. Basically, you specify, well, the create event with the name of the mutation and what you're going to pass, and then the return. From the client's perspective, they only need to know about create event, and you can also specify when you make a change, add some event, delete some events. You can also say, I only want to get the ID out of the return. So for now, we return the entire event. But remember, the client can still control what they want to receive. I already talked about this, but I will just jump very quickly. The difference now between get event and the list events is your data may have a lot in the database, and you may want to do pagination in there. So by default, AppSync, we already give to you a data connection to DynamoDB, and we do the pagination for you already. So you don't have to worry about these things. I will demo that again. And lastly, something I saw on Twitter that people were very excited about this session is, has anyone tried to do WebSockets on AWS? OK, brave. With AppSync, when you create an API, you already have the WebSockets and everything already configured for you. And all you have to do is to connect to the endpoint, and that's problem solved. From a GraphQL perspective, what you do with WebSockets is something called subscription, where you can say, if anyone changed the data on comment on events, for instance, which is something you can actually comment over there. Sorry, my bad. If anyone changes the data inside my comment type, I want to send part of the data to my client. So if someone actually works in real time trying to change the data, you will receive part of the data that has changed through WebSockets. When you look at a mutation, if anyone from the client, imagine you have multiple clients, and someone mutate that data, add a new comment on the event, anyone who subscribed to their own comments will receive the data that has just been updated. The good news about this is that not only Dynamo is in place, but actually a lot more data sources. Summarizing this, and then we go to AppSync specifically, with GraphQL and some of the capabilities AppSync will give to you, you can now do all of this on the right. You can do offline through the library we're going to give to you. You can do search using Elasticsearch, for instance, and you can mix and match Elasticsearch in DynamoDB if you want. It doesn't really matter what data source you're using it. And then aggregations, like I said, and everything else. Now, AppSync. If you ever tried to do GraphQL before, you probably know the hassle of setting up a GraphQL server and setting up everything in general. So AppSync is a service that's a managed GraphQL that will do all these capabilities that we talked to you and more. Think about WebSockets and all those other pieces. It would need to actually make a better GraphQL implementation and scalability, and actually more than this. One of the hardest pieces about GraphQL is authorization and fine-grained authorization. Because you can give the power to the clients that they can do pretty much everything, what they want to return, what they want to receive as data, you also want to be in control into what sort of data, even if I'm giving them the schema and the query, what sort of data they can have access to. That's a different game. So that's why AppSync comes into play, into providing easy access to other AWS services, fine-grained control access, and also managing all the GraphQL for you. The way AppSync works is as simple as this for now that you should know. Is you need to upload a schema, which is a GraphQL schema that I told you about it. Once you actually create that schema, you need to connect to data sources. Think about DynamoDB or a Lambda function or Elasticsearch, because that's where the data resides. GraphQL only query the data. And then after that, you configure your clients to connect to this endpoint, and you get access to real-time streaming data through WebSockets and everything, blah, blah, blah. But how does the subscription work? I've just tried it now, and I want to know how my data will look like when I'm trying to query or when I make a change. How does that look like? Is this. Remember when I told you about subscription and mutation? When someone, like on the left side, adds a mutation called add post, the person or the mobile app or whatever app who's already connected to the AppSync endpoint will receive a new notification or a new data, new, let's say, frame, the right word for this, through WebSockets and say, the data is the key, and this is the data that someone added. So that's how AppSync will abstract all of this away from you. In an architecture level, because we love icons, when you're using AppSync, this is what you can use today. You can have AppSync to connect to DynamoDB table, one or more or multiple. And if you don't know how to create a DynamoDB table, give us the schema, and we will create a DynamoDB table for you as well. And if you're not so sure that maybe you have a DynamoDB table and you're trying to play if GraphQL works, we can import the DynamoDB table and generate the schema based on the DynamoDB table items definitions you have. And if you have a legacy application or something that doesn't fit right here, that you still need to have that nice GraphQL language, you can use a Lambda function to talk to anything that you can talk. Think about another API or a application running on premises, and you can still have all the query language capabilities, but now using a Lambda function as a connector to where the data is. Elasticsearch, of course. From an authorization perspective, we're actually going to use Cognito for this. Cognito will manage the user management, all the authorization piece, and everything else. However, the next question, when I was learning AppSync as well, because I tried to learn as much as I can, and using the same tools you have, so I can come here and give those talks, is when AppSync needs to connect your data, the first question I was asking myself is perfect. It needs to talk to Dynamo. Dynamo has an API that makes a query to the data. There's got to be some, where is this API? I'm not seeing it. AppSync has something called resolver. You have a data source, which is where's your data? And the resolver is, how do I connect to this data? How do I query that data? Does it have pagination? Or does it have to have something special? This is how it works. I wouldn't even say behind the scenes because I can show you in the console. But AppSync will get your data, and the request template using Apache Velocity will say how the query will look like, about DynamoDB, get item, batch get, you name it. And then on the response template, we will actually get the data from the data source and return in a way GraphQL understands. Another question I was asking was like, OK, that's perfect. I understood how the API works and how everything else behind the scenes work. But what if I'm working with multiple DynamoDB tables? Think about an enterprise, right? You have multiple DynamoDB tables, multiple data somewhere. You need to make relationship between them. And one of the tables get throttled, or you get some issues because something happened. I don't know. How do you know that that query actually went wrong? AppSync has something called logs. You probably have heard of it. And logs will stream to CloudWatch logs, and it will tell you exactly what operations you went through each data source and how long it took for those operations in particular. So you can see from their normal resolver flow, that image that I showed you previously, this is how the logs were going to be structured. Exactly how the request came in, before it made the API, how we returned, and everything else. But I talked to you about offline access. How can you provide offline? There are many different ways you can give offline access to your applications. I'm going to show you only one for now. But when you provide offline access, it's not that you're just using cache to make something happen, but you also need to think about so many other things. Especially if you're using a very, very rich UI, how are you going to make a change that if someone also made a change, how are you going to resolve that conflict? Who wins? Is that client the last one? Or how are you going to change your UI to reflect that change? Do you follow an optimistic way of make a change and hope for the best and change the UI unless you receive an error? Or you go for a more pessimistic approach. You say, well, I received your change, but I will talk to you later. If we try to think about how offline would actually work for you, is something like this in AppSync, right? This is the default behavior. Hopefully you can see at the back. Let's say Jane just wants to make a new change on the document. So she actually goes offline, and actually she ends up making another update. And then John comes along and says, well, I actually want to make another change. And now you actually have a new version of that document. And the problem is, John is actually not offline, but Jane is. So they may have a problem there. When Jane comes back online, what we will actually do by default is, well, the last updates or the server actually will win. But we give you the capability to do any custom change, any custom conflict resolution you want to do. You can use Lambda for this. So let me go back in here. So when we're doing this, we give you the same very request templates and that resolver logic that you can say, make that change, but if the data already exists on DynamoDB, for instance, well, don't make it. Or do the opposite. If the data doesn't exist, then actually make that change. Or you can go even more advanced. You can say, I already know these things. I have an application that works with a product catalog, inventory, and data warehouse. I have something that's way more complex than a DynamoDB query will look like this. What do I do? What's next for me? When you are configuring that conflict resolution, there's something really neat and a more advanced feature called conditional check failed handler. You can pass a Lambda function to do whatever logic you want, and then you can say to AppSync, yes, I resolved the conflict, go ahead, or do something else, or fail for the client who's actually asking for the data. So that gives you a way more flexible approach to actually do conflict resolution. Just because we're giving you that, it doesn't necessarily mean that you have to build Lambda functions for every possible conflict resolution. And it also means because you now have subscriptions for GraphQL, you actually shouldn't be making changes and making notifications to the client all the time. I don't know about you, but I've faced it so many times installing new applications on my phone that probably 20 minutes later, my battery was actually drained because there are too many notifications or too many telemetry data being sent somewhere else that I didn't know. And because I'm a stubborn, I thought, let me just do a network let's say Wireshark, and look at all the networking calls that my applications are doing. And it's just staggered to see so many requests being made just for the sake of my application is offline. Let me just keep retrying in a loop. Because why not? What could possibly go wrong? And then your phone keeps hitting up. So when you're using these features, please keep your customers in mind, especially their battery. They may not have the latest phone in the world. OK, enough of talking. Now I can do some of my pieces. If you are interested in following this more, and if you want to see some of the codes I'm going to use, these are the best resources I've found, and I particularly tried all of them before I came onto stage, and I'm going to use one of them for today. So keep those in mind, try this afterwards, and play around with the AWS on the console as well. I particularly find that building something from scratch gives you a better learning experience if you want to learn everything top to bottom. But these projects are already there for you, explaining also how to structure your code, how to structure your GraphQL queries, and everything else. All right. Oh, yeah, please, in case I forget, please don't forget to add the server in there. All right. Now is the time that I ask you, please don't use Maven, don't use BitTorrent, don't, be a kind citizen for me, please. This is the console for AppSync. I'm just going to show you very quickly how it is. If I quickly create an API, I can say, let's say, London Summit. That's London Summit. I could create something from scratch, or I can just use a sample schema. Can you actually see at the back? Do I need to increase my screen? OK. That works for me. And the very same schema I told you about is actually being created for you right here. Don't worry, we're going to go into more details. I'm just going to hit create, because the Wi-Fi may play a trick with me, and I just want to wait for that. When I create a first AppSync API, at the back of it, like I told you, we will create the DynamoDB tables for you already. We create a schema for you as a sample. We create the API. It's already there, ready to be queried. And we also give you a simple API key as a means for authorization for now. Obviously, we would want you to use Cognito or something more advanced, but for now, this is what it comes from the default. If you see at the very top, you can see, please do not refresh. 10 minutes before I came to the stage, I refreshed my page, thinking that Wi-Fi was actually doing something wrong, and everything failed. So please, don't do like me. Wait. Don't be the anxious person. All right, so now I just wait. Wait. While we wait, on the left-hand side, we will see Schema. I think I can get that already. I'm telling you not to be anxious, and I'm being anxious on stage right now. All right? Maybe Wi-Fi is actually not there. Let's actually wait. If none of this works, at least I have the code already downloaded, so I can play around and show you. So I'm going to give 5 more seconds and see if that changes. Like the drum things now. OK, sounds like it's doing. If you scroll to the bottom, what GraphQL also gives to you, actually, AppSync gives to you, hopefully people are not going to kill me for saying this, is on your simple API, we give you a simple application for iOS, Android, web, and React Native, already showing to you how to connect to AppSync, how to make those GraphQL queries, and you can actually make use of this right now. And we also give you an AppSync configuration file with the API you just configured, and the API key and everything else you possibly need. So to get started for AppSync is actually a no-brainer from this case. Well, if the Wi-Fi works, it's actually working now. Cool. So let me see. Let me see if the table has been created already. OK, well, you know what? Let me show you the code then. I think I already got in here. OK, so I was separating what I was going to do to you. So the next one is another session. But if you want to come along, we're going to do another session at 2:55, or we're going to build a single-page application from scratch. So that code, that simple code for web, is actually this one. You see all the code on the right, on left-hand side. You see the source code. And remember when I talk about schema, mutation, queries, and all these pieces? This is actually what a query will look like from the front end. So the front end will actually use this and use a GraphQL client and just make a query to the API that we just have created for us. So the way you build front-end applications in that sense doesn't really change much. You still build the normal using Vue.js, better than React, right? No, OK, fine. So you can use Angular if you wish, or you can use other pieces. But the whole point here is that you have a GraphQL folder in here, or something similar, where you can separate all the queries you're going to make. So you can separate your components quite nicely. And then when I talk about WebSockets as well, you probably remember this. This, what we're going to show live, is we're only interested in new comments into new events. We're going to add new events. And if someone makes a comment on that event, I want to be able to receive an update wherever I am. So then hopefully I can switch off the Wi-Fi and see if that works. OK, not there yet. So let's do this now. Let's download this config file. And I already installed the application in case the Wi-Fi wasn't going to be the best. So let's do this now. If I go to mobile, this is a React, by the way. I still like React. I just find that Vue.js is much better. So the only thing I need here is I go to source, and I have a, oh, it shouldn't be there. Hang on. It's over here. Sorry, my bad. I just need to get that AppSync. Oh, this is where I fail miserably on stage, right? You know what? Let's just go over here. Oh no, really? So let's see if that works. Oh, I need to install my stuff. My bad. So unfortunately, we need Wi-Fi to get all this working. My apologies. So I will try to use the console for now. Don't worry. Green. Thank God. Thank God. Thank you. Thank you for waiting and not being the anxious person. All right, so let's use the console for now, and then we try the npm install and everything else that I show you. So let me just refresh, just in case I don't have anything on my cache. I want to make sure everything works for now. Oh, wow. If I see you on a laptop running BitTorrent, I'll find you. So even DynamoDB is taking its time. Oh man, that's not nice. Okay, well, for now, let me just do something here. In the meantime, something's doing. The demo gods are not there with me anyway. When I was trying to learn AppSync, or GraphQL in particular, one of the things I found particularly hard, because I'm not coming from a front-end perspective, I mostly do backend, was it wasn't easy for me to understand how to do authentication, how to do WebSockets and all these pieces. In the sample app, there's actually something called AppSync, both as a SDK or a client, and also something called Amplify. It's going to be here, hidden away in these pieces in here. So Amplify, if I can open up my browser later, is all of the stuff that might be difficult at the beginning to do authentication for your client, to do web storage, or offline caching, or all of these pieces actually provided by a client library called Amplify. So if you don't know that or haven't seen that yet, this is something I would strongly recommend. I knew nothing about front end from React, and I was able to do authentication and offline in about an hour without doing anything. Yeah, I don't think that's going to work now. Which reminds me that the other session I have is 45 minutes hands-on installing stuff, everything from scratch. So I will need to find a replacement for this. Because this is going to take a while, and I don't want to disappoint you for this, I will open up for questions for now, at least, and then we can keep interactive. In the meantime, we are praying, fingers crossed, and you're not using your laptop. Other than this, my apologies for that. It's something I wasn't planning, and I think no one plans for this. So, ready to take any questions you want? Yep.
So it looks like you provide a schema, and then it generates ways for you to do CRUD, to create an update and stuff. Can you also do things like push things onto SQS and do background processing as well?
Mm-hmm. Sure. So the question is, I consider you define a schema for GraphQL. You make a create, update, delete, read, and such. But what if I want to make an update and then make a push a call to SQS as a message, and I can do further processing in there? If I go to, anyway. So when you go to GraphQL and define your schema, you can say, this is my type code message, and I have events and I have comments. The message will be a message I want to send to SQS or something like this. You can say the data source will be a Lambda function, and the Lambda function or the resolver will call to SQS and put the message in. So in this case, you can say, everything that's basic into my DynamoDB, I can just query as it is. Everything else that I want to call another REST API or possibly send a message to SQS, SNS, you name it, you can use a Lambda function for doing this. So you can extend this. In GraphQL terms, everything will be a object type in your schema. And then that type or that object, you can, in AppSync terms, you can say, call this resolver. And this resolver will do whatever it has to do. This case could be a Lambda function. It could be something else. Cool. All right. Yep. Yeah, sorry. Sorry, I'm not hearing. Deployment, is that the question?
What deployment tools would you use?
Okay, the question is, how do I deploy this? What would be the deployment strategy for doing something like this? So CloudFormation for now would be your deployment strategy. You can use code pipeline for doing CI/CD type of things. Because GraphQL is just a schema file that you define as a JSON or, I don't know, JSON YAML or something, all you would have to do is actually have your schema inside your source code and treat your GraphQL API as pretty much the same as a Swagger for REST API. So you could have your schema.json for GraphQL in the same source code, and then you could use GitHub or code commit. When you do a push, you will actually use CloudFormation to update that schema for you, if that makes sense. Cool? Yep. Sorry. I'll go to you, Emmet.
I was just going to ask, how would you implement search in your GraphQL schema, especially if you back up with Elasticsearch? Like, what would that search endpoint look like in your GraphQL query?
Sure. So the question is, what if I want to do something more advanced? What if I want to make a query to DynamoDB and I want to make a search using Elasticsearch, for instance? How would my schema look like? So I don't have it here because internet's not going to help me for now. But on those resources, let me show you. It will just end up being another type inside your schema. There's the one on the right-hand side, David3. So Nadia, who's actually one of our developer advocates for mobile, he actually created some examples on actually doing exactly this. And there's actually a few other blog posts about this. The way you do it is on your GraphQL schema, you actually create a new type, let's say search comments or something like this. And in those types, you can say, which data source should I use to get that data structured in the way I'm looking for? And then you connect to Elasticsearch. And then through Elasticsearch, you will be able to make that query just fine. From a GraphQL perspective, it's all about how you define your type. And then AppSync perspective is, where is the data? And how do I get there? So that should be just a schema changes. Hope that answers. OK.
So this one is in the cloud, right? So what is the sort of development test workflow? Is there like a local emulator? Or how do I write tests for this?
OK, so for now, so the question is, all of this is in the cloud, right? This beautiful cloud thing. How do I test this locally? How do I make sure this will work? So for GraphQL perspective, just as a schema, you have tools for this. The whole experience of AppSync, for now, is just the cloud. In AppSync, we also added the debug resolver flow, and we also add capabilities for you to mock responses for different data resolvers in case they're offline or something that's happening. So for now, we built all of this into the console using client and SDKs, but we're definitely open for feedback on this and how you would like to see it. If you don't mind, catch me on stage afterwards. I'd like to see how we could do this. OK. So let me just check one thing. Let's see if in case the console opened. Otherwise, I will just call it a day and hopefully to see you somewhere else. Yeah, it's just not working. Apologies for this. I had about 25 minutes of hands-on to show you. Let's do this. Catch me on Twitter. Let's do two things, actually. At least because for those of you who stayed here, I can make that promise. Every second Tuesday of every month, 4 p.m. London time, we have streaming on Twitch. It's called Build on Serverless. It's something I'm running with all the Lambda runtimes available. Think about how would I build something in serverless using Java, Go, .NET, or something. I'm going to make a new episode about this and stream and make it recorded. And then we can build something together. You can see us building live. And then that's something I can promise for you right now, at least to compensate on what unfortunately happened. Otherwise, catch me on Twitter. I have other videos I can share with something with you. And the whole product team as well is on Twitter. So I'm happy to connect you with them as well if you need. Other than this, thank you for joining. Thank you for your patience. And yeah, enjoy the rest of the day.